All right, good morning, everybody. Same as always. Be good if someone can just confirm that they can both see and hear me. Just give me 1 minute and then we will start. All right, good. So, as you can see on the screen here, we are scheduled to talk about chapter 6. Now, I know between yesterday and today, there may have not been a lot of time to do a chapter like that, but hopefully it wasn't so bad in the sense coming from the Roman number chapter and understanding what questions we have to be ready for. The format is going to be the same. It's just a matter of having different a different number system to get on top of. So in this case, we have the Babylonian number system. Let me zoom in a little bit. There we go. And because they didn't have a paper format to work with, they had to be creative and used clay to make indentations in an efficient way to do their writing and record keeping and all that. So we end up with two main symbols, the symbol for 1 and the symbol for 10. And then we just string some of them together to make larger, to make representations for larger quantities. That of course happens up to a point. Up to a single place can only hold 59, and they decided to count in groups of 60. Why 60? Well, no one knows with 100% certainty, but that was what they decided at the time. So again, we have to be able to convert back and forth as our starting point. So let's say here conversions. And I certainly don't want to go to any sort of arithmetic before I'm perfectly comfortable with the conversion questions. Not that you're converting when you do arithmetic, actually quite the opposite, but more the conversion questions gives me a chance to just get on top of how the number system works, little things I need to be aware of, and so on. So until there are any questions, I'll just go ahead and run through some examples, but feel free to interrupt me at any stage. So we want to, what's the easiest one perhaps? The easiest I would say is from the Babylonian system to the decimal system. So let's make, say, a three-place number here. Let's say we have something like that, and then a nice space so it's obvious. Then maybe a couple of tens here. And so a nice space for maybe just something like that. So now I have to convert this to a decimal number. Now you can scribble and write whatever you want. Maybe for some people that aren't super comfortable with this right from the start, you can have a section to help yourself cross over to the decimal number system To explain, well, okay, the rightmost place represents the ones. Then I'm looking at number of groups of 60. Then I'm looking at number of groups of 60 squared, or 3600, if you will. So the ones position is 3. I'll put it in brackets because we're not quite decimal yet. We're doing them in their own places. The number in the 60s place is 46, and the number in the 60 squared place is 12. So then I have to put that together. So that means I'll go left to right. It's 12 groups of 3600 plus 46 groups of 60 plus 3 leftovers, or 3 groups of 1 if you want to. It's totally up to you. And then let's see what we get. I have my calculator in my chat box so we can see it as well, but feel free to practice it on whatever calculator you are going to use in your test. 12 times 3600 plus 46 times 60 plus 3, and we get 45,963. So going from the Babylonian system to our decimal number system is probably the easiest question. Any thoughts on that direction of conversion at this stage? No thoughts? Everyone is without thought this morning?
Yeah, I think it's quite easy. Probably
This
that's why
direction, for
no
sure,
one is saying
yes.
anything.
I mean, that's a good sign.
Yeah,
When there's silence, it's either very good or a very bad sign.
bad. Yeah, I think this time it's good.
Okay, good, good.
Yeah.
Now, the other direction is a little bit more involved, and the most important thing I would say is for you to come up with a plan and a layout for how you are going to do it, and then just always do that. Have some consistency. Brings confidence that you know going in. If this is the question, I know what I'm going to do. I'm going to lay it out like this, and I always do the same thing. It's when people start doing, well, okay, if it's simple, I'm just going to do that shortcut. And if it's more complicated, then I'll come up with something else. But I don't really know what I'm going to do until the question comes. That is where uncertainty and anxiety starts to form. So if I'm given a number, let's say 125,372, just random number, and I need to convert that to the Babylonian representation. I'm going to say, well, okay, I need to have my different, let's say here, groups of 60, or let's say, no, let's not say it like that. Let me say my group size is going to be my first column, and the largest group I can fit in here, well, I need to check. 60 cubed. I don't know. Let's pretend I don't know what 60 cubed is. 60 cubed. 60 cubed is, whoopsie, it's a line there. 216,000. So I know, ooh, no, that's a little bit too big. I can't even fit one of those in. Okay, so that means the largest group size I can start with is 60 squared. So that's 3600. And then I'll go down to 60 to the power of 1, which is just 60, of course. And technically it's 60 to the power of 0, which is just 1. So I just need to make sure that I can fit in the largest group size in terms of powers of 60. And in this case, 3600 is the largest one. Then I want to know how many times does that group size fit? That's going to be my next column. That's my choice. Of course, yours could look differently, whatever makes sense to you. But I want to decide on my layout beforehand. So for example, if I look at the first one, a simple division of 125,000, the given number, divided by 3600 will tell me how many times that fits in because that's the basic concept of division. So we'll calculate that, 125,372 divided by 3600, silly line, and we get 34 with a little bit left over. So 3600 fits in 34 times. Now, how much of the number have I used? Well, 34 groups of 3600. That's multiplication. So let's do that. 34 groups, 3600. And we get that we've used 122,400. Almost all of it. Wow. But obviously, there's a little bit left over. There's a little bit left over, which will be the difference between what amount I started with and what amount of that I've used. So I'll show the little difference there. 125,372 minus 122,400. So that is a difference of 2,972. And that leftover I need to use up with my smaller groups. But in essence, that's how I'm deciding to lay out my answer. So whenever I have a question, convert this decimal number to a Babylonian number, this is what I'm going to do. And I have confidence that I know what to do. The number specifically will just affect the group size I start with and so on. But the layout, I already have confidence. I know what I'm going to do. So now I have to focus on the leftover, 2,972, and I have to fit in groups of 60. So that is going to be division, 2,972 divided by 60, and we get that 49 and a bit. 49 times that 60 can fit in with a little left over, but we'll worry about that later. So how much of my 2,972 have I used? Well, 49 groups of 60, and that is multiplication. So I'll calculate that. 49 groups of 60. And that then uses up 2,940. And now the difference, what I have left over is pretty obviously 32. And that 32 will be mopped up by the leftover ones place, using all of them, leaving nothing, and I'm done. So then over here, I can go up at the top and say, well, maybe let's slow down. It's our first example. Let's not do that. I can have my sort of go between. I can't do it up here, sure. I'm going to have a three-place number. Remember, for the ones, the 60s, the 60 squareds. So how many groups of 60 squared? 34. How many groups of 60? 49. How many groups of 1? 32. So that then leads to my Babylonian number. First place, I just represent 34, so that's 3 tens and 4 ones. space, nice and big space. I see people in tests not having a big enough space or having too big a space between the tens and the ones when it's one place. So be aware of the spacing that you use. Second place here, 49. So try to make my tens a little bit more pointy. 49, 9 little ones here. Then a nice space. Then 32. And I'm done. Easy peasy. If I make a plan and I practice and I prepare, going in, I know how I'm going to do it. I'm going to look at my group size. I'm going to look at how many can fit in of that group size. What have I used? How much is left over? And then you see here that this column of the how many times it fits is exactly essentially the answer. I just have to convert it a little bit. And that layout that I've now decided on is going to help me in chapter 7 as well, because the same thing is going to come up in terms of a template that I can use. So it's just a matter if I have a larger group of 60, 60 cubed, we've learned that's 216,000. Maybe my number's big enough to accommodate that group. Then I have to always start with the largest one I can fit in, so that the number of times any group can fit will never be over 59, because that's not allowed. So that's the other direction for the conversion. How do we feel about that one? Often I see people mix them up. For one direction, they use the opposite method and sort of cross them over. I don't know. It's a completely different method for a completely different question. It's in the topic of converting, but it's not the same question. The direction of the conversion determines how I'm going to handle it. So separate these two conversion questions in terms of the strategy that you're going to use. Any thoughts of any kind about this kind of question?
Hi, Professor. I just have a question. You mentioned in the lecture that in the test we're not allowed to like write the decimal number when we're converting. Is that just like for addition and subtraction, but we're
Yeah,
allowed
no,
to draw
go
a
double
chart like
check.
this?
When you're converting, like these questions we just did, then of course you can write whatever you want.
Right.
But the
Okay.
same as for Roman, if you're doing the arithmetic, then you have to stay within that number system. Because it's not a
Okay.
conversion question, it's trying to ask if you understand and can work the method of addition or subtraction or whatever.
Okay. And if we show our work, like for example, like this one here, I do it a different way. Like it's very similar, but just like in a way that I understand better. And if I show
Yeah,
my work
no,
like that,
there's many ways you can lay out,
yeah,
have your answer laid out. Uh,
yeah.
as long as you show some work, so that in case, let's suppose I accidentally write 33 instead of 34 for the first number of
Hmm.
groups, then everything else is going to be wrong. But because I showed my work, um, I'd be able to identify, oh no, it was just one little mistake, and she still knows
Right.
how to do everything.
Okay. Okay. Thank you.
Any other questions? Looks good. Okay. Well, there should be questions. Otherwise, I cannot fill an hour and a half. There needs to be some questions for these chapters because the different kinds of questions are limited. We don't have a lot of variety for these chapters, but I guess that could be a good thing. Now, we can definitely revisit the conversions if you need to, but I guess we'll move on to some arithmetic, starting with the easy one, addition. And now, same as for Roman numbers, we want to, well, in terms of a test question, we want to stay within the Babylonian number system and use the same method. That will be the written one, right to left. But if you were to make up your own questions and you want to check them, then of course you'll have to do a conversion because there's no Babylonian arithmetic calculator. So it depends on your needs. Some questions for multiplication, a few more examples, subtraction. So let's just go through maybe a couple of each. We'll see, a couple of each. So let me just make one up. Now I'll line this up for you so I don't waste your time writing all these little symbols, but of course it's going to be in a way presented like exercise 6.5, for example. Everything's in a line and you have to identify the number of places and line them up. That's definitely the first step in all of these, to line things up correctly. So I'll just make one up. Do we want maybe an easy one, easy-ish. So let's say we have 10 there, and let's suppose we have 2 there, and let's suppose we have maybe 4 of them, maybe like that, and we're adding, let's say maybe a 1, let's say maybe 2 tens, and let's say we're adding, let's make it a lot, maybe like that. There we go. So notice the spacing, that even though the first one here is a 10 and then it's followed by some ones, they're not in the same place. There's a big space between them. Whereas the last number has tens and one symbols and they're close together. They should almost touch. Okay, so I have no idea what these numbers represent. I also don't really care. I am simply emphasizing and raising my awareness of the addition method. So I'm going to focus on the right column, the ones column. So then I have, what do I have here? I have 46. Now remember, I can say 46. I can't write 46 in a test. But if you're building up to that, maybe you scribble some stuff in the margins, sure. If it helps you, just know that you can't do that in the test. So I have 46. I just say it over and over, 46. Okay, now I remember. Plus 52. So that is 98. So now, just for now, because it's our first example, I'm going to write some stuff here so you can see something. So I have 46, and then I have 52. And that's obviously going to be 98. But I can't put 98 in a single place because I'm counting in groups of 60. So that's going to be one group of 60 plus another 38. So the one group of 60 will carry over to the next column, and 38 will stay behind. No, now just emphasize, in the test you can't write these decimal numbers, but just so we have something for our first example. So that's the same carryover. I'm just working in groups of 60. That's the only difference, really. That and the appearance. Then I'm moving on to my 60s column, which is 1 plus 2 plus 20. That's not really right. It's one group of 60 plus two groups of 60 plus 20 groups of 60. But because I know I'm in the 60s column, I don't have to say that groups of 60 every single time because it's not going to change. So I casually say 1 plus 2 is 3 plus 20 is 23, and that can certainly fit in. Ooh, that was an ugly one. There we go. Then I move on to my 60 squared column, which is casually 10 plus 1. It's not, it's 10 groups of 60 squared plus one group of 60 squared equals 11 groups of 60 squared. And I'm done. Now, if you want to verify that this is correct, the only way to really do that is to convert each number, add them up, and then check if that matches your Babylonian answer. But I'll leave that to you. In a test, we will only see this portion. We can't see or write any decimal numbers, though we of course will say them as we do our little arithmetic portions. All right, so addition. Well, let's do two of each since otherwise I will not get to 1030 in any way. Let's see how difficult can we possibly make it just by making all the places super big. So let's say we have, I don't need to make the first one that big, but I want the other ones to be fairly big. Maybe a space here, maybe 24. I'll just put a 1 there. Maybe this one could be 30. Ooh, I wanted actually one more. Let's make it, whoopsie, where's my erase? 35, let's say. And let's make this one big. It's a little tedious to write these down. It was much more efficient for them because they just made indentations, right? We don't have that. All right. Now, maybe what's a good idea is to give you a minute to see, can you make any progress with this? Where do you get stuck? And then we will do it. Maybe that's a good idea. So let's see what we can do here to give you a timer. Well, we don't have to finish it. Let's maybe give ourselves a few minutes and see how far we can get with this one. I'm assuming you've written this down, so I'll show a screen for when we'll come back, and then you can work on that in the meantime, see how it goes. I need the wire cutters. Yeah, okay. Okay, we're back. Now, of course, everyone works at a different speed, so it's hard for me to judge exactly how much time. So let me know for the next one. Do you need more time, less time? And of course, the subtraction and multiplication might be a little more complicated. But anyway, even if you didn't finish it, of course, it's early, right? Our test is only on Monday, so lots of time. But it's good to be aware, like, oh, I get stuck here, or oh, I don't know even where to start, or whatever it may be. Okay, so let's do this without, or should we do it without? Well, yeah, let's do it without writing anything down, and I'll show you how I would do it. Because you have a calculator, right? You just can't write anything. You could put numbers in your calculator. No one can see that. So we are starting with our first column. Let me just move down a little bit. There we go. Our first numbers are 24, 24 plus 59. Now, even if you don't want to do it in your head, you ideally should, but if you want confirmation, what did we say? 24 plus 59. And you can see, we see it is, my cursor is weird. It is 83. So now you just have to split 83 into groups of 60. So that'll be one group of 60 and 23 left over. Then we move on to the next column, which is now 1 plus 47. It's 48. 48 plus 35. Now let's say you don't want to do it in your head. It's nice for me to show stuff in the on the screen as well. What did we say? 48 plus 35. And you can verify one way or another. Whoopsie, where's my screen? And you can verify one way or another that that's 83 again? No way. Oh, that's hilarious. Oh, that's a nice coincidence. Wow, that's an unfortunate coincidence. That is random. Anyway, that'll be one group of 60 again with 23 left over. And then your last column, the numbers are very small, so that'll be 13. Oh, that's funny, 283s. Is, for those that finished it, is that what you got as well? And for those that didn't finish it, did you have any questions? Anything I did that you don't like? Anything at all? This is the moment. This is your moment to say something. Well, not really. You'll have more moments. So, a couple of additions. Definitely the first one to start with. I see people jump ahead, like, oh no, I need to get to subtraction. Yeah, but you should build up to subtraction and get your conversions. Make sure you understand the number system. Build up with addition, and then go on. We can do a deep. Then you can decide subtraction or multiplication. They're a little different in their method, but we'll do them in order and do subtraction next. And again, I'm not going to take from your problems and exercises. I'll just do a random one. So let's write here subtraction. We'll do a little one, and then we'll see how hard can we make it, and we'll give you some time to work on that one. So subtraction, we want to have something that has the borrowing effect. Let's just do a 1 there. We could repeat this process in multiple columns, but it's essentially the same. Let's say we have something nice and big enough. Let's say 33 here. Let's suppose we have 11. Why is it so small? It's okay. Minus. Let's just say we have maybe a 26 there, and maybe we want to subtract 42. All right. Do you want time for this one, or should we do a first one? Maybe we should do a first one. Yeah, no. So what's the idea? It's the same idea as always for the method. It just looks a little strange. That's all. So I'm in my ones column. I'll maybe use some color. Let's get some color going here. So I have to do 11 minus 42. And that's not gonna go well. I don't have enough. So I'm gonna borrow from the 60s column. How much do I borrow? I always borrow 1 of that column value. See this 1 as a little baggie that has 60, this one bag has 60 little things in it. Now when I borrow it, I split open the bag, so I have 60 things, 60 ones. Now you can group those however you want. I just want to see them all. So I'm just going to list a bunch of tens. In no way is that a representation, but it helps me to not get confused. Now this is how much I have. To take away 42, I now have 71 to take away 42. Do it in your head, do it on your calculator. I really don't care that much. I'll do it on in the chat so that we can see it. What did we say? 71 minus 42. And we get 29. Oops. 9 little ones. That's always fun to do. Not. Okay, there we go. Now remember, this guy is gone. The one I borrowed is gone. So what I have left, when I now go to the 60s column, I have 32 left, and I need to take away 26. So that'll leave me with 6. And then I move on to the last column. 1 minus nothing, it's just a 1. And there we go. So it's the same method. Everything is the same except the appearance, the symbols that I'm drawing, and the fact that I'm now working in 60s. Everything else is the same. So we should try and focus on the similarities, and then it's not as intimidating as it might appear to be. Any thoughts or questions on this subtraction example before I set up something a little bit more spicy? Is everyone quiet because it's so easy or because you're behind schedule and you have no idea what's happening?
I think it's all good.
Good. Good.
Yeah.
Babylonian numbers, they present a little more problems in general, in my experience, than Roman numbers do. But if I just look past the foreign appearance, it's really not that strange.
But Stephen, I found these Babylon numbers easier than the Roman numbers. I don't know.
I have heard that from some, but definitely not the majority. It's just different, yeah. Different people take to different things.
Hmm.
In a way, if I look past the appearance, I don't know. This might, you could argue that this is a little closer to our decimal system. It doesn't look it,
Yeah,
but
probably because of that. Yeah.
yeah, we'll talk about pros and cons between the two in a second. Let's see how bad can we make the subtraction. So let's say here I have 2 and then I have a little empty symbol and I have a little empty symbol. Then I have to subtract. It doesn't even have to be a lot. Let's say 22 and let's say 45. Let's go with that. So I'll give you a minute just to make sure that you have it written down. And then how much time do we want? Uh, let's say we take, I don't know, 2 and a bit. Oops, that's not what I want to do. We want, oops, we want to have enough time. So I'll give you a couple of minutes to see if you can make any progress in this one. All right. Hopefully that was enough time, but it's hard to guess what we need. Oh, that's a huge circle now. What did I do? No. There we go. All right. I need some more space at the top, perhaps. Okay. So we are starting in the ones column. We have nothing. Take away 45. That can't be done. So I'm going to go borrow. There's nothing to borrow from the next column. So I have to go borrow for that column first. So I'm going to go borrow one of these guys. That splits open into 60 of the next column. So now I have 60. Now I have to borrow. Let's make it blue so we can tell them apart. I have to borrow for the ones column. How much do I borrow? And then
One of the 60s.
I always borrow one. Borrow one. So now I might need to split one of these tens open so I can actually see it, right? I'm borrowing one of them. So let's say from that one. So I have, let me make it pink again. So of that 10, I still have 9 left. Little confusing. And then the one that I borrow splits open into 10 little ones. So then I have, for my ones column, 60, because there was nothing there originally, so I just have the 60. Take away 45, so that'll leave me with 15. Now, what do I have left for my 60s column? I have 59. Take away 22. 59 take away 22. That's 37. 37. And then this little one that I borrowed from the 60 squared column isn't there anymore. I should have crossed it out. And I just have the one left. Oopsie. Come on, line. There we go. And there we go. So I wouldn't start with one of these if you're not ready, but eventually it's nice to see, okay, how bad can this get? And then nothing else is really that bad. You can use colors, you can use whatever you want except decimal numbers written down. Of course, on your calculator, of course, that's going to be a decimal number. What you say to yourself in your head, of course, that's going to be a decimal number, but you can't write it down. You have to, because it's a written arithmetic, it has to stay within the number system, the Babylonian number system in this case. But yeah, color helps a lot. People underestimate the benefits of color to help us keep track of things. Any other thoughts? So this one is probably the worst it can get, right? I can't think of anything more difficult than this in terms of subtraction.
Stephen, I think I'll have to log off and back on because I can't see your screen at all.
What happens when you click on the little live red next to my name?
All I see is a black screen with two blue squares twirling.
Does anyone else have that problem?
Yeah, I was also having some problem seeing your screen. I just had to refresh my page.
Okay.
Okay.
That.
Worst case, you could try the YouTube stream. It's hard to say. I just there was a power outage and I just got it back before nine o'clock. So who knows how fast the internet is? It could be something on my end. I can't do much. So
Um,
YouTube might be your backup option.
yeah, but Stephen, I can see you. My
Okay.
screen is working. Yeah.
Okay, good.
Thank you.
Yeah,
Somehow
I'm back on.
refreshing it, yeah.
Yeah,
But yeah, let
back
me
on
know if
then.
you're having a problem and you just want to pause, want us to slow down a little bit, yeah.
So thank you.
And of course, this is backed up to the YouTube playlist eventually. I don't know if I've done that for yesterday's session. I don't think I have. So whenever you see a session not being at the end of our playlist, just let me know because sometimes I forget. All right, multiplication time. Multiplication, I find, well, yeah, I think it's easier. You don't have this borrowing nonsense. Now, the borrowing, I don't want to sidetrack right now, but um, the borrowing complications that uh, many people may experience as students learn subtraction for the first time, um, it's unnecessarily complicated. And it's because we're doing it right to left. There are other ways, like if you do left to right, and some workbooks demonstrate that, but it's not a main part of the teaching methods, unfortunately. Then it's actually much easier. You don't have the big borrowing and chain borrowings together issue at all. But not many people teach that anymore. The written version of arithmetic is usually right to left, though there are other ways. But that's a topic for another time. Let's do multiplication. We certainly have to start with right to left because that's what you'll be expected to teach, probably. Now, like I said yesterday, I'm not going to do a short condensed version of multiplication. I want to see the detail for my own benefit and um, from a teaching perspective as well. But we will keep the second number nice and small so I can do multiplication in my head if I want to. So let's take let's say a three place number here. Let's say maybe 11 and then maybe 34. Oh, it's a 5, never mind. And then maybe, yeah, just maybe a 3 here. Why not? I'm going to multiply that by, I don't know, you pick a number less than 10. Actually, it could be 10. 10 is actually nice. Let's do 10.
We can do it by 9.
I already picked 10. 9. We'll do 9 next time.
Okay.
Let's make an easy
We'll
first
do it.
example. And 10 is super easy to multiply by. But no, we'll do 9 next time. Yeah. So I focus on the ones place of this first number. 10 times 3 is 30. And I write the representation for that quantity. Let's clean up my 10 symbol. Then I am going to move on to, sorry, that was the ones column. Now I'm going to move on to the not tens column, the 60s column. And I'm going to multiply 10 by 35. It's not really 35. It's 35 groups of 60 equals a certain number of groups of 60. So I'll start over here and I'll pad it with what is equivalent to a 0 symbol. So now I have to do 10 times 35, that's 350. So I'll just write stuff on the side here so that you can see what I'm talking about. But remember, for a test, that cannot actually be something you write down. So we have 350. We want to make fit in groups of 60 into this. 9 groups of 60 will be a little bit too much. No, not 9. I mean, 6 groups of 60 will be 360. 9 is way too much. So we're going to have to go 5 groups of 60 using 300 and then 50 left. Now, of course, this would happen in your head or on a calculator or something not on the page. So I would have 5 groups of 60 relative to this 60 column, like this, and then 50, 50, like so. Because it's all relative to the column I am in, I can relax how I say things and not attach groups of 60 after every single thing I say. But that can be a little bit confusing to some. Well, how can I put 5 groups of 60 in the 60 squared column? Well, it's because in this 60s column, I'm not multiplying 10 by 35. It's 10 times 35 groups of 60 is 350 groups of 60, which is 5 groups of 60 groups of 60 plus 50 groups of 60. But it's so tedious to say, we drop that groups of 60 at the end. That is just at the end of everything we say when we're in this column, making it a much more convenient system that I can reduce little bits of arithmetic as if it's actually smaller than what it is. Then I move on to the 60 squared column, and my answer is going to start in that same column, and I can pad it with quote unquote zeros to line things up nicely. And then I have 10 times 11. I'll write it down. That's 110. It's not really 110. It's 10 times 11 groups of 60 squared is 110 groups of 60 squared. But it's all relative to that column. So I have one group of 60 plus 50. Oh, 50 again. Wow. 50 left. So I will have 1 to the next column, 50 in that column, and now I have to add everything up. So yes, in this more detailed version, there's more to write down, but it's so systematic, it's much nicer to keep track of. The general rule is the less I write down, the more I have to do in my head, and that's where things get a little mixed up sometimes. So I add them up, 30, 50. I need to work on my 10 symbol, make them nice and pointy. And this one is another 50, 55, and then a 1. So it's a little longer, but it's much safer this way. Of course, realizing that this can never be seen by anyone. All right, how do we feel about multiplication? I think subtraction is worse because of the whole borrowing. Multiplication is just a little bigger layout, but nothing too complicated. All right, so let's make another one, giving you a chance to think about it first. since we have the time, we'll do, let's make them big-ish. I should probably not start that far left then. Let's make this one nice and big. Let's say here, oh, my 10s are not good. They need to be way more pointy. Ah, come on. I'm obsessing over my 10s. Pointy. Nah. Let's multiply that by 9. Because why not? And of course, now you have your calculator available. Sorry, you have your calculator available if you ever need it, so you don't have to feel that it's overwhelming. These numbers can get a little bit bigger. So let's see what we can do in terms of time. Let's say maybe a couple of minutes. And then we'll see how it goes. All right. Rinse. All right, where are we now? Okay, we're back. Good. Okay, so let's go through this one nice and slowly. We have 46 times 9. Let's suppose you don't want to do that in your head. You're tired of this. You could just do it on your calculator. That's fine. 46 times 9. And we get 414. So now I just need to break 414 up into groups of 60 because it's too big. 414, how many groups of 60 can I fit in there? Well, 7 groups of 60 will be 420, and that's too much. So 6 groups of 60 will be the best I can do. That gets me to 360, so 54 left. Does everyone agree? Those tens are not pretty, I apologize.
Yeah, it makes more sense, Stephen. Thank you so much.
Okay, so that is our ones column done. Next column is the tens column. I will pad it because I know that is going to help me keep everything in line and always going to be the case. Now I have, oh, a nice 40 times 9. I'll just show it so it's everyone can see it. 40 times 9. Though I don't think we needed a calculator for that. 360, oh, it's perfect. Well, that's a very good example. Wow, randomly I made a good example. That is perfectly 6 groups of 60. So 6 groups of 60 relative to that column with nothing left over. That's a good example. It's good to see this one. Then we'll go on to the last column. I'll set it up, padding with my empty place symbol. And I have 23 times 9. Let's see it. 23 times 9, 207. How many groups of 60? 3 groups of 60 gets me to 180, and then I have 27 left over relative to that column, of course. Then I simply have to add these up, add these together. So let's do that. Nothing here but copying the first column down, the 54 it was. Oh, this one, 2, copy down the 6. Often this addition is not very complicated. This one, maybe a little bit. I have 6 plus 27, so that's 33. So a little update there, not much. And then copy down these 3. And I'm done. Let me zoom out and see this one. Like that. Piece of cake. With a little bit of practice, there's really no reason to not do well in quiz 2. I think it's more, quiz 2 is easier because it's much more straightforward. You know exactly the questions that are going to come. You just don't know exactly what the numbers will be. Quiz 1 has some more variety in the puzzles and what are the rules going to be for Lady and the Tiger. Some more variety, which makes things interesting, but more difficult for a test.
Stephen, can we use a pencil to write a test?
Of course you can. I never write anything in pen because it just sets me up for making a mistake and then have it be all messy.
Yeah.
So no, absolutely. You can always write in pencil.
Yeah. Okay.
Yeah. Colored pencil, whatever you want. Yeah.
Okay. Thanks.
Whatever works for you. Now, not that it's a test question, but pros and cons of the Roman versus the Babylonian system. Why are we not using them anymore? Well, I guess different reasons. So sort of the Hindu-Arabic nations, and I guess China as well, it's something very similar. Their system was just way more efficient, and it eventually overwhelmed anything else to what we have today. But that's a chapter 7 issue. Basic pros and cons of the Roman system. I'd say the Roman system has a pro that it is very much decimal. We're still sort of counting in tens and hundreds and stuff like that, which is nice. It makes it more relatable and easier. A con is that if I look at, for example, 49 versus 150. Now, in our decimal system, we can see that the bigger number, or the much bigger number, has more digits. It has an extra hundredths digit, visibly making it longer, making it bigger. So you can just look quickly, oh, this one's bigger. I don't know by how much necessarily, but I immediately know the second one is a bigger number. It has a longer representation. Whereas if I do the Roman representation of these quantities, 150 would be CL. Sorry, that L looks a little bendy. L. And the representation for 49, well, 40 is XL, 9 would be IX. So now what's visibly inconvenient is the smaller quantity has a longer representation. And that happens all the time with the Roman numbers, that the length of the representation goes up and down, and it's not directly relatable to the size of the quantity that it represents. So you have to look, like, what is that? Oh, it's actually bigger or smaller. Whereas a place value system, like our decimal system, like the Babylonian system, you could look, if it has more places, it's a bigger number, period. So the length of the representation does not always correspond to the size of now I'll say quantity, or to the quantity that it represents. A larger quantity can have a smaller representation, and that makes it visually a little bit slower to compare numbers. Whereas the uh, Babylonian, the con is that it has very limited symbols that it can use. Now, that's the downside of the format of the clay and the medium that they're using. It's not their fault. It wasn't by choice necessarily. But because I have so few symbols, I have to, I look at, sorry, I have to use them over and over and over in little clusters to make um, digits, essentially, place values, which is a little inconvenient to quickly read. Ooh. So they had to decide, okay, more than 5 tens in a cluster, and that's visually very hard to spot. More than 9 uh, of these little one symbols, and that becomes tricky as well. So it becomes very subjective. When is it okay? When is my cluster getting too messy? So it's a little hard to read visually because of so many little symbols stacked together. The pro is sort of the opposite of this, of the Roman con, that because it's a more direct place value system, If I have a number with 3 places versus a number with 4 places, it's always going to be the 4 place number is the bigger quantity. That the length of the number of places, at least, in the number directly tells me something about the size, which sort of has our decimal system has the same um, benefit because it has the same place value system. The digits just look a little bit more convenient and more variety when we use 10 instead of 60. So a con, I guess, could be here that base 60 is not it's not ideal. And another downside is if you look at our number system here, our we're counting in tens, so we're looking at groups of 10, and our digits, our symbols that we have available is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 of them. And that's where number systems become efficient. If your number of symbols match your group size that we call the base, if they match, then you have much more efficiency. And the downside of the Babylonian system is that we're counting groups of 60, yet we only have, I guess, 3 different symbols. We have a 0, a 1, and a 10. And that creates potentially visual confusion with clusters of things that have to repeat. In our decimal system, we don't have to repeat within a certain place. There's no repetition. There's a symbol, a unique symbol for anything we want to have in that place. There's no clusters of symbols being repeated in a specific place. So it's sort of naturally we tend to go with what is the most convenient, uh, what has the most immediate benefits. And when your group size and your number of symbols match perfectly, that is going to allow you to do certain comparison things very quickly. It just has a lot of convenience built in, and that's why it became the dominant um, number system. Just sort of a side note, not anything that is going to be tested. We know our test questions are converting back and forth, 3 kinds of arithmetic. So there are 5 questions that you have to prepare, and then it's just a matter of doing that same thing in the different number system. Now, as we go over to chapter 7, it's really the same thing in terms of kinds of questions and variety, converting and arithmetic. We just want to now get a little closer, get away from the history slowly and get a little closer to our decimal numbers without it being exactly the same. Because as soon as it's exactly the same, then I just stop thinking because I'm so used to doing things in the decimal system. I don't think about addition. I don't think about borrowing. I just do it because I'm so used to it. So I want to keep that slightly uncomfortable zone, slightly a little less familiar, so that I can keep thinking about the methods being the same, everything's pretty much the same, but I want to get a little closer to the familiar symbols instead of the quite foreign looking Babylonian symbols, for example. That is all I have for today. Are there any questions anyone wants to bring up right now?
Uh, Stephen, I just want to have a double check. So for the test, I mean the first test, the midterm one, are we going to have only first 5 chapters?
No, it's only 3, right?
Okay, first 3. You mean that?
First 3 chapter. Well, It's barely chapter
Okay.
one. Chapter one, the only thing that can come out of that is what are the different forms of reasoning,
Mm-hmm.
example, pros and cons. That's it.
Okay.
Chapter two is really the main focus. Negation problems, Karuji Sudoku, Lady the Tiger. There's a lot of things happening in chapter two.
Mm-hmm.
And then chapter three is our general problem solving. And then you
Mm-hmm.
see part two technically starts with chapter four, but chapter four is just for interest's sake.
Okay.
So the first test will be chapters one to three, and then the second one will be chapters five to seven. We're actually going to leave out eight because it's not really anything new. It's more just if you're interested, here's some extra stuff.
Mm-hmm.
So really just three chapters for each test.
Okay.
Yeah,
Thank you.
no problem. Any other questions? So we have a little more time in case you need to catch up for until Thursday. But chapter 7 will be similar. We're just looking at number systems that are, I'd say, simpler and drifting towards our as close as we can get to our decimal system. How did we actually get to our decimal system? But the kinds of questions you'll see will pretty much be the same. So again, what helps, I think, is focus on what is the same between all these number systems, and you'll see a lot is the same. And then the few things that are different, then they don't seem so overwhelming. The first two quizzes are done in the same time window. But you still submit them as separate files. There's a quiz one and a quiz two, but you have 2.5 hours to do them in whatever order you want. You can flip back and forth between them. You could do two first and then one. It's totally up to you. So time you save, if you do quiz two fast, for example, then you have a lot more time for quiz one. So it's all together really, but it's still two separate tests. Technically, you still submit two separate files. It's just done together. Yes. All right. I will leave you to it. Feel free to ask questions as you need to. Our Discord chat's always open. It's there for you to use as you need to. We will end things there then.